Welcome to all. See, what all principles I told in the first class and subsequently in the second class, I have written something on the board because of shortage of space, little small I written. So I will dictate. If by chance, if any part is not visible, I am going to dictate. I think I check the camera, it is almost visible. And you should write big letters. Here space problem is there. Sometimes theory questions are asked. So important concepts you can call concept, or some people tell rules or principles or explanation for static friction. That is summary of what all you told. One by one I will tell. See here, fifth one I wrote red color. I wrote and rounded. And eighth one, these are very important. For fifth and eighth, little more explanation I will give you. Okay, start. One by one. See, this everything is told for you so far, but brief summary. See, whenever a body is in contact with a rough surface, and if the body either tends to move or moves, sometimes it may not move, but tendency is there to move. See, for example, see here, I will apply a force. It is not moving, but tendency is there. See, now it is moving. It tends to move or moves over the contact surface. Resisting frictional force will be developed at the contact surface and will act on the body. Resisting frictional force will act on the body under consideration. Okay. Second point, the resisting frictional force on the body will be in a direction opposite to the direction in which the body tends to move or moving. That is, if the body is still at rest, that is, if the applied force is not able to create motion, the frictional force is there. It is actually opposite. Which side you want to move, it's opposite. Or if it is already moving, again opposite. So, will be in a direction opposite to the direction in which the body tends to move or moving. Either tends to move or moving, and hence the resisting frictional force will either prevent the body from moving. See, the purpose of resisting frictional force is to prevent the body from moving. If the body is still at rest, means it has not yet moved, or will oppose the motion of the body if the body is in moving. If the body is at rest, that is still not the limiting case came, it is not started moving, then it will prevent the motion. Whereas if it is already moving, by chance it is moving, then it will oppose the movement. That is, second one is called dynamic friction. First one is, you can make a note here. The first one, when the body tends to move, static friction, or moving, dynamic friction. Okay, then 3. If the body is still at rest or it is on the verge of moving. See, body is still at rest or it is on the verge of moving. It is considered as a case of static friction because motion has not started. Whereas if the body is moving, it is considered as a case of dynamic friction. Okay, you can make a small note here. Our continuation is only static friction. Reason I told you. Fourth one, very, very important. If the body is on the verge of moving, it is considered as a case of limiting static friction. I told FF limit yesterday. It is a case of limiting static friction. And in case of static friction, limiting static friction, remember, when the body is at rest, it is called static friction. If it reaches the stage when it is on the verge of moving, still not moved, it is called limiting static friction. If it is moving, it is called dynamic friction. Next, in case of static friction, the resisting frictional force developed is a self-adjusting force. This is very important. See, this is also very, very important. I tell, one point number 5. This is 6 actually. Okay, this is 6. This is 7. Okay, no problem. Number problem. This is 7. This is 8. Okay, no problem. 8. This is 9. Number missed. Okay, now see. In case of static friction, the resisting frictional force developed is a self-adjusting force, and only that much frictional force will be developed required to prevent the motion. I give an example for you. If you have 1000 rupees with you, and if you eat somewhere, if the bill comes 600, you pay only 600, don't give 1000. But you can spend maximum 1000. That 1000 is called limiting one. Okay. Next, sixth one, very, very important. When the body is on the verge of moving, that is the case of limiting friction, the resisting frictional force developed has a constant ratio with the normal reaction. Or you can either call that way, or you can write limiting frictional force developed is proportional to normal reaction on the body. See, when it is proportional, it is called has a constant ratio. This constant of proportionality is called coefficient of friction. See, right here, more explanation little later. More explanation little later. For this one, there is more explanation little later. Once again, next. Seventh one, the coefficient of friction depends on roughness of the surface. It does not depend on area of contact. You can make a note. Sufficient. Depends on roughness of the contact surface. How rough the surface is, that is called coefficient of friction, depends. Eighth one, this I told last time. The angle made by resultant reaction. See, statement, brackets are not to be seen. The angle made by resultant reaction with normal reaction is called angle of friction. Somebody will ask, sir, what is resultant reaction? See, resultant reaction means resultant reaction considering both frictional force and normal reaction. Last class I told you, see, frictional force this way, normal reaction this way, resultant reaction acting. See, if it is frictional force is this way, normal reaction this way marked, FF resultant. So the angle, after last class already told, the angle made by the resultant reaction is considering both frictional force and normal reaction. Close the bracket. So sentence is what? The angle made by the resultant reaction with normal reaction is called angle of friction. Now ninth one, till the stage of limiting friction is reached. That is, till the stage of the body being on the verge of moving, not reached there. Till that time, actual frictional force developed will be less than the limiting frictional force. Once again, money matter. You have 1000 rupees with you. If the bill till the bill reaches 1000 rupees, you have 1000 rupees with you. Till the bill reaches 1000 rupees, the money paid by you is always less than 1000 rupees. See, till the stage of limiting friction is reached, the actual frictional force developed will be less than the limiting frictional force. And you can make one more note here. When the stage of already over, see here, already over somewhere. Where I wrote it? Somewhere I wrote it here. See here only. See here. And you can add one more thing, or further you can add there. Sixth point once again. What? And finally, when the stage of limiting friction is reached, that is, body is on the verge of moving, then the frictional force developed is exactly equal to limiting frictional force. That limiting frictional force equal to mu into normal reaction. This I will tell you now. These are the concepts. You can now here see. See, for sixth one, more explanation. Then for eighth and ninth also, little more explanation later. Little later. Right now. Later. Right now. Second round. Okay, make the note. What all extra point I told, if you want, you can make a note here. I will rub the board and then, see, I will maintain the statement number 6 and statement number 8 and statement number 9. And this side, I will explain little more details. These are all not required. Already over. See, all I finished, this I not removed. For sixth one, ME means more explanation. See, when the body is on the verge of, this is all over last time. When the body is on the verge of moving, that is case of limiting static friction. Let R be the normal reaction on the body and FF lim, LIM, be limiting frictional force on the body. Remember, this R and FF are acting on the body, very important. Then FF limiting frictional force is proportional to R, or FF limit is mu into R. Mu is called coefficient of static friction. And also ninth point, I told here, see ninth point, not ninth point, eighth point, sorry. Eighth point, see. The eighth point is, I already told you, we always want to mu. Okay, now, by chance, if the angle of friction is required or given, if phi be the angle of friction, then mu equal to tan phi. Okay, mu equal tan phi. This I will remove now. See, 1 minute now. I will already, this concept of mu equal tan phi already shown last time, but still, once again I will write here. See, here only, for eighth one, just to understand. Simple example I will give you. See, imagine body here. See, body here. Body weight is acting here. See, there is a, imagine you are applying a force like this, simple language, a force to move. Then this is the contact surface. And this is due to P, let the body be on the verge of moving. On the verge of moving, very important. This is very important, on the verge of moving. Or you can tell limiting static friction case, static friction stage is reached. Then see, when moving it to right side, frictional force will be to left side. Okay, then this is the normal reaction, R. This is frictional force, FF limit. This will be equal to, I told, mu into normal reaction. You know already, mu into R. Okay, now, see here. Prepare a graphically mark here. For FF limit this way and R this way, let this be resultant reaction. See, this is resultant reaction. Don't put resultant reaction on the body or R resultant. Now, angle made by resultant reaction with normal reaction is called phi. Therefore, see here, tan phi equal to, see the triangle here. If you take, see, it will correctly come here now by law of triangle of forces. This is this one. See, tan phi equal to FF limit divided by R, or FF limit equal to tan phi into R. But we already know, see, already we know that right here, we already know FF limit equal to mu into R. Therefore, see, compare. Therefore, mu equal to tan phi or phi equal to tan inverse of mu. This already I told you last time. Okay, now the most important concept. Remember, one small puzzle is coming up now in this class. You should think and answer it. Okay, I'll remove this one now. Now, lastly, make a note. Very, very important. I repeatedly told, ninth case. Come to ninth case. This is actually, remember, rarely in examination questions are asked. Till the stage of limiting friction is reached, the actual frictional force developed will be less than the limiting frictional force. To explain this one, I will give an example for you. See, one mini example here. Example. Consider a block, see, from body of weight, see, weight equal to say 20 kilonewton, heavy load 20 kilonewton, resting on a rough horizontal surface. For the surface, mu is coefficient of friction given in the question. See, let coefficient of friction that is mu is 0.3. Okay, 0.3. Imagine given, that is, imagine what? Imagine given in the question. Given in question. Okay, now see here. This block you write here now, and we have to consider, we are applying, and let P be the force, horizontal force applied on the body to right side. So understand, to right side, purpose right side, so as to move the body to right side. Move the body to right side. Right side. This is P. Horizontal force P. Okay, then automatically what will happen? Resisting frictional force will come. See, wait, I'll do one thing now. I'll remove this one and put one more sketch and make more clear, because concepts are there. I'll forget later. 20 kilonewton load, mu equal to 0.3, sufficient for me. Okay, sufficient for me. See, just now I told we are applying a force P. See, I told already, purpose of P is to see that body is on the verge of moving. Remember, this P is for body on verge of moving. How many times I have tell? Verge of moving, or it is a case of limiting friction, LF. Limiting friction, okay, right. See, 20 K and down, normal reaction R, P. Now, since it is a limiting case, FF limit equal to mu into R. I told mu is 0.3 into R. Sigma Fy 0, R minus 20 equal to 0, R will come 20. Sigma Fx 0, P minus mu R, 0.3 R equal to 0. R substitute R equal 20. Your P will come 6 kilonewton. So, what is 6 kilonewton? 6 kilonewton is what? See here, 0.3 into 20. See, this 0.3 into 20, or this one, see, these two are what? These are FF limit. FF limit. Okay. Note, FF limit equal to mu R. This 6 kilonewton is, see, once again I will write here, mu is 0.6 into 20 equal to 0.3, not 0.6, okay, 0.3, okay, 0.3 into 20 equal to 6 kilonewton. Okay, now, suppose we apply a horizontal force P of 4 kilonewton. See, that is, now imagine, we don't apply 6 kilonewton. Make a note here, 4 kilonewton. Note that the body is on the verge of moving when the force P reaches 6 kilonewton. If you apply a force of 6 kilonewton, the body is on the verge of moving. Now do one thing. You apply a force of only 4 kilonewton. Like you have 600 rupees in the pocket, but you eat only for 400 rupees. So you pay bill of only 400. Don't give 600. Okay. Then see. Then the body will be, see, then the body will be still at rest, because limiting friction, that is body on the verge of moving is for P equal to 6 kilonewton. Already solved earlier, already calculated little earlier. See here, this side. Thus, therefore, the frictional force developed, say FF, not limiting, FF actual developed is not equal to mu r. Instead, FF, see, FF frictional force actual developed is less than what? FF limit of okay, more decoration, that is equal to mu into r, that is equal to 6 kilonewton. So the frictional force developed is not 6 kilonewton, it is less than 6. Therefore, now we should not write FF equal to mu r. It is wrong. Simply consider as FF as an unknown reaction which is not equal to mu r. Or if you want to find it now, see, find it. See how to find it. See. Consider the equilibrium. See. Body weight is how much? 20 kilonewton. You are applying a force of only 4 kilonewton. See here, 4 kilonewton. Actually it becomes 4 only, but don't by heart 4. This is normal reaction R. This is FF actual developed, or simply FF you can call later. See, sigma Fy equals, see, this is not equal to mu r. This is not equal to mu r. This is wrong. You can take FF equal to mu r only when limiting case comes. So sigma Fy 0 upward positive plus r minus 20 equal to 0. Therefore, your r will come 20 kilonewton. And sigma Fx 0, take right side positive, upward positive here, right side positive here, plus 4 minus, see, FF actual developed equal to 0. Therefore, actual frictional force developed, or that is FF actual developed equal to only 4 kilonewton. See, I told here, till the stage of limiting friction is reached, the actual frictional force developed will be less than the limiting frictional force. Or simple money matter, you multiply by 100. If you have, see, last time how much? 6 kilonewton, 6,000 rupees, okay. If 6 kilonewton, 6 kilo means 1,000. If you have 6,000 rupees and if the bill comes to 6,000, it is limiting case, correct, fully exhausted. But if you have got 6,000, maximum money you can pay is 6,000. Maximum frictional force possibly 6,000, 6 kilonewton. Suppose the bill comes only 4,000 rupees, then what you do? You actual money to be paid is not 6,000. It is less than the limiting case, that is 4,000. So much crystal clear. Okay. Now, one important puzzle is there. I decided not to give today because it's a very, very important puzzle. Answer is very simple. You should think. I thought of giving today, but see, if I see at the end of the class, there are so many people who don't go to finally end. When they see I am explaining so many things, oh, understood everything, okay, leave. So I will give in the next class. Next class, I will start with the puzzle. Some brain teaser. See, one separate uploading is their brain teaser. I will continue that one. This will be added there also. In the class right now, I will ask you. Let me see how many will correctly answer. Answer is very, very simple, but little logic required, structural knowledge required. Okay. Now, that's all today, sufficient. I told last time, next class I'll do more problems. No, these all I forgot to give final summary. So now everything is ready. Now we will go to non-stop or marathon questions. Okay. We will meet next time. Thank you.